This video is going to take a look at three things. First, the definition of the derivative completed for simple polynomial equations. They'll already be completed. We'll just take a look at them. Two, from this information we're going to generalize the power rule, and then we're going to take a look at four basic examples. So what you see here are two examples of using the definition of the derivative on a polynomial equation. I'm going to cover up this one with my hand right now. Feel free to pause this at any time. I'm not going to run through the information because you've already done this, plenty of times. So getting a final result of 6x. Again, pause it if you want to take a look at this a little closer. Okay? So the slope of the function f of x equals 3x squared. The slope of that function at any point along that function can be found by taking 6 times the x value. Okay, the other one, the function f of x equals x cubed. Again, you see the work here, resulting in a slope value, the derivative value of 21x squared. Again, if you want to find the slope anywhere on 7x cubed, take the x value, square it, and multiply it by 21. Alright, so now let's take a look here. If I write these two slope values a little differently, if I write, instead of saying 6x, if I say this is 2 times 3x to the first power, and also if I take a look at this 21x squared and write this a little differently, if I say that this is 3 times 7x squared, and if you compare these to the originals, it looks like this squared value has dropped by a degree. Okay, and it looks like the original exponent comes out front as a multiplier right here. Okay, so take a look at this function as well. It looks like the degree of this polynomial has dropped by 1 degree. Okay, and it also looks like the original exponent has come out front as a multiplier. I know this seems magical, but you see the work right here. And we're just trying to make a shortcut at this point. Okay, so if we would come up with a general formula for a polynomial equation. So if the original polynomial equation reads a times x to the n power, the derivative of that, the slope of that function, think about what happened now. This power decreased by 1 degree. And what happened to the original exponent? It came out front as a multiplier. Alright, let's take a look at some examples here. Alright, first example, f of x equals 3x. Again, I know you guys are probably fine with this since you learned it last year already, but we'll say f prime of x is equal to, drop that exponent by 1 degree, the old multiplier, or the old exponent comes out front and becomes a multiplier. So final answer, 6x. That's the one we just did. Again, you see it here. Look at the notation too. F of x and f prime of x, just the notation for the first derivative, the slope. Okay. Also, if you have y equals 7x cubed, you can write the first derivative as y prime. Drop the degree of the exponent, and the original exponent comes out front as a multiplier, which gives us 21x squared for our solution there. Okay, another one, a little more lengthy version of a polynomial. Just to show you another way for notation for a first derivative, instead of f prime of x or y prime, we'll get more into the details of this later, but dy over dx, you can isn't slope actually change in y over change in x? So think about that just as another style of notation, and we'll use our power rule. Drop the degree by 1, bring the exponent out front as a multiplier, and we'll do that in our head and say 3 times 5, which is 15. Plus, drop this exponent by 1. Now it's down to a 1. I'm not going to write that. And then we'll bring this exponent out front as a multiplier times 3, 6. Take the derivative of drop this by 1 degree. It's x to the 0 power, which is 1. And bring the original exponent, which is a 1, out front as a multiplier, negative 4. And we know the derivative of a constant is 0. I'm not going to write that, plus 0. Okay? This power rule even works for rational exponents. I know in the printout it doesn't look as nice as I would like for a fractional exponent, but this is the exponent 5/3 and 2/5. So for a derivative, f prime of x is equal to, drop 5/3 by 1 degree. There's 5/3 minus 1, so we have 2/3. And we're going to bring this 5/3 out front as a multiplier. Plus, now we need to drop the exponent 2/5 by 1 degree, which gives us negative 3/5. And we need to bring the original exponent out as a multiplier. And as we simplify, we'll see that the first derivative is 10/3 x to the 2/3 power plus 16/5 x to the negative 3/5 power. And there's a few examples for you.